Welcome to the final section on polymorphism, runtime polymorphism. Unlike duck typing and operator overloading, which are unique to Python, runtime polymorphism is a standard OP concept found in all object-oriented languages. It relies on inheritance and method overriding to determine which version of a method to execute at the moment the program runs. 1. The mechanism inheritance and overriding. Runtime polymorphism is achieved when a parent class defines a general method, and one or more child classes override that method to provide specific implementations. When a generic reference variable points to a specific child object at runtime, the correct specialized method is executed. 2. Setting up the hierarchy. We define a parent class, shape, with a general calculate_area method. The two child classes, circle and rectangle, both inherit from shape and override this method, providing their own specialized area calculations. The shape method is never intended to be run. It's just a placeholder. 3. The polymorphic function. We create a generic function, print_area, which accepts an object named shape. It calls shape.calculate_area without knowing if shape is a circle or a rectangle. The actual version of the calculate_area method executed is decided at runtime based on the object's actual type. 4. Testing runtime behavior. We call the same generic function with two different objects. When we pass circle, the circle.calculate_area is executed. When we pass rect, the rectangle.calculate_area is executed. The method call is polymorphic because its exact behavior changes based on the object's type, and this choice is made by the Python interpreter during execution. To summarize, runtime polymorphism is essential for building flexible systems where specialized objects share a common interface. This concludes the module on polymorphism. Our next lecture 20.01, Abstract Classes and Interfaces. See you there.